Good day to you children. Today we will be learning about Euclid's fifth postulate. In the previous classes we learned that postulates are the statements which are considered to be the truth without any kind of proof for a particular stream of study. And Euclid's postulates belong to geometry only. So before we go to the fifth postulate, which is about the parallel lines, let us look at some basics of geometry. Right, these are all the stuff which I have learned so far from first standard. So the very first thing which I want you to learn is recall is point. As we learned from Euclid's definition, a point is a dimensionless, or in another words, a point is a geometrical element which has no length, breadth or height, or even if you want to state it simply, point is a dimensionless geometrical object. So how do we represent a point? A point is represented by a simple dot like this. And whenever you name or label a point, we always use capital letters like point A, similarly point E or point X. So like this, points are represented or denoted with capital letters, and they are always represented as simple dots. After point we have lines. Lines are nothing but arrangement of points. They only have one dimension, which is length. Lines do not have any thickness or width to them. They only have length. So in lines there are three types. The first one is a line. Or you can also call it as straight line. In a straight line we represent it by drawing it like this. This is a straight line. And also whenever we say it is a line, we have to attach two arrows at the end. These arrows represent that the line can be extended in both the directions indefinitely. To name a line, we can either use two capital letters. The capital letters must be the points, 2 points on the line. Okay, so this can be called as line AB, or simply use a small letter, line L. Similarly, if I were to draw another line here, another straight line, arrow marks which represent the continuity of line, I can either name it as line A with a small letter A, or consider any 2 points on the line, say Z and P. So this is line PZ or line A. Both the ways are correct. After a line we have the second part, that is line segment. What is a line segment? A line segment is the part of a straight line, or you can also say that a line segment is a terminated line which has been ended, which cannot be whose reproduction has been stopped, or like this. This is a line segment with two endpoints at the ends. Okay, the 2 points at the end are known as end points. And to name a line segment, we always use capital letters at the ends. We name the endpoints and call it as line segment AB. And before we forget, This can be written as AB with the symbol on the top like this, which is extending. This means line AB or line L. Similarly, when you want to write that it is a line segment, write it as AB bar. Just a bar, no arrow marks. If you put 2 arrow marks, then it is a line. If no arrow marks, then it is a line segment. The third one is a ray. You usually use rays whenever you draw the angles, right? So ray is a line which has one end point and it can be extended indefinitely in one direction. Rays can only be extended in one direction, whereas lines can be extended in two directions. So here ray is a straight line which has one end point and it is extended, or it can be extended in the other direction. So this is ray P Q. We always name rays using capital letters just like the line segment, and it can be written as PQ with a ray on top. This represents the ray which is only going, or which can be extended in one direction, but it has an end point at the other end. Alright, so now since you recalled about point, line segment and rays, now it's time for us to visit the parallel lines. Parallel lines are the lines which are or which have a fixed distance between them. The distance between parallel lines is always fixed. Look here, these two are parallel to each other, these two lines. Say M, N, line M and line N. Line can be represented using either two capital letters or one small letter. So I am using small letters. Line M is parallel to line N. This symbol, these two lines in the middle of the letters represent parallel. So line M is parallel to line N. They have a fixed distance between them. They always have a fixed distance between them, no matter from where you measure them or from which point you measure them. Whereas when the lines are non-parallel, like this, look here, line A and line B, these are non-parallel lines. Just look at the distances here. The distance between these lines, here it is wider. If we go further into the lines, then the distance between them is shorter, right? Here the distances are shorter compared to here. So these kind of lines are known as non-parallel lines. If I extend these lines like this, okay, they'll eventually meet each other. Whereas the parallel lines, in case of parallel lines, no matter how much you extend them in this direction or in the left side, no matter how long or how much you extend them, they will never meet each other because the distances between them is fixed. That's why they will never meet each other. So when we say parallel lines, those are the lines which never meet each other, or the lines which have a fixed distance between them. You can write it down. Parallel lines are the lines which have a fixed distance between them and they never meet. Whereas this figure 2, name this as figure 1 and this as figure 2. In the figure 2, we saw that line A and B meet after a particular point, or the distance between them is not fixed. It goes on reducing, or it goes on increasing if you come from the top. So these kinds of lines are known as non-parallel lines. Now consider two lines x and y, and x is parallel to y. They are parallel lines. The distances between them is same. So now consider a third line which is intersecting the lines x and y, say at points A, and B. The third line intersects our parallel lines at points A and B. Let this line be line Z. Okay, this third line which intersects our parallel lines is called as a transversal line, or a transversal, or simply transversal. So the third line which is intersecting the parallel lines is known as a transversal. If you look carefully, then the transversal makes so many angles here: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So the transversal makes 8 angles with the parallel lines, and each of these angles have many interesting properties which you have learnt in your previous years. In Euclid's fifth postulate, his main focus was on angle 3, angle 5, these two angles, and angle 4 and angle 6. So before we go ahead and understand what these angles have anything to do with the fifth postulate, first let us understand each of these angles. Alright, so now angle 1 and angle 2 are called as linear pair because angle 1 plus angle 2 would give you 180 degrees. They are known as linear pair. Same goes for angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. Similarly, angle 7, angle 5, angle 8, angle 6, angle 4, angle 2, angle 3 and angle 1. They are all linear pairs, means the sum of those two angles will always be 180 degrees. Now angle 1 and angle 5. Similarly, angle 2 and angle 6. Similarly, angle 3 and angle 7, and angle 4 and angle 8 are all known as corresponding angles. This angle, this angle, top angle, top angle, bottom angle, bottom angle. So these angles are called as corresponding angles, and they are always equal. In the linear pair, the sum of the angles was 180 degrees. These are known as linear pairs, right? The first ones were linear pairs. Whereas the second set of angles, that is 1, 5, 2, 6, 3, 7, 4, 8. Look at the figure which to recognize those angles. 1, 5, 3, 7, 2, 6, 4, 8. These angles are known as corresponding angles. They are called as corresponding angles, and they are always equal to one another. If angle 1 was, say, 100 degrees, then angle 5 will also be equal to 100 degrees. I am not measuring them, I am just giving you an example. The corresponding angles are always equal. Now similarly, angle 1 will be equal to angle 4, angle 2 will be equal to angle 3, angle 5 will be equal to angle 8, and angle 6 will be equal to angle 7. because these angles are known as vertically opposite angles. Vertically opposite angles are always equal to one another. So moving ahead, after linear pair, corresponding angles, and the third set of angles, which was vertically opposite angles. In this figure, those are angle phi is equal to angle 8. It is one of the examples. There are still 3 pairs of vertically opposite angles present in your figure. So after vertically opposite angles, we have the fourth type of angles in the parallel lines and transversal, that is alternate opposite angles. The fourth type of angle is alternate opposite angles, and they are also always equal. When the lines are parallel, these angles are equal. For example, angle 4 will be equal to angle phi. These are known as alternate opposite angles on the interior of the transversal, interior of the lines or the transversal. See, these are our lines. These are the angles which are in the interior side. These are interior angles, whereas 7, 8, 2 and 1, they are exterior angles. So angle 4 will be equal to angle phi. They are interior alternate opposite angles, to be specific. If you just want to say, if you don't want to be specific, then they are interior opposite angles only. If you want to specify them, they are interior alternating opposite angles. Similarly, angle 6 will be equal to angle 3 because they are also interior alternating opposite angles. Now there are exterior alternating opposite angles. They are angles 1 and 8, angle 2 and 7. They are exterior alternating opposite angles. Okay, in alternating angles there are two types, interior angles and exterior angles. So one of the examples, angle 1 is equal to angle 8. They are exterior alternate opposite angles. For interior, the example is angle 4 is equal to angle 5. They are interior alternate opposite angles. Last but not the least, we have angles on the same side of transversal. All these angles which is linear pair, corresponding angles, vertically opposite angles, alternate opposite angles, all these angles are equal or they follow their properties if and only if the lines are parallel to each other. So when we talk about angles on the same side of transversal, we have, this is our transversal here. Okay, so now which are the angles on the right side of the transversal? Since this is our transversal, on the right side we have 4 angles, 2, 4, 6, 8. These are our 4 angles. Similarly, on the left side of the transversal we have 1, 3, 5 and 7. These are the angles on the same side of the transversal. So in this type of angles, when interior angles on the same side of the transversal are supplementary. Supplementary means their sum is equal to 180 degrees. That means when you add two of those angles, that is when you add two of those interior angles, that is angle 4 and 6, when you add these angles, their sum is 180 degrees when only when the lines are parallel. If the sum of the interior angles on the same side of the transversal is not 180 degree, then your lines are not parallel. So it goes both ways. If the sum is 180 degrees, then the lines are parallel. That is one way. If the lines are parallel, then the sum of the angles will be 180 degrees. That is another way of saying the same thing. So either angle 4 plus 6 must be 180, or angle 3 plus angle 5 must be 180 degrees. Since we have told that x is parallel to y, since we know that the lines are parallel, we can confidently write that angle 4 plus angle 6 is equal to 180 degrees, and similarly angle 3 plus angle 5 is equal to 180 degree. So what this whole thing, what we discussed so far here about interior angles on the same side of the transversal, or the angles on the same side of transversal, this whole thing itself is Euclid's fifth postulate, which says when the two lines are parallel, then the interior angles on the same side of the transversal are supplementary. That is not the actual statement. I have modified the statement for your understanding. As you can see, this is the actual statement of the fifth postulate of Euclid, and there is a funny story behind it. Since we keep saying that postulates are the statements which are assumed to be true without any kind of proof, but Euclid himself did not believe that this statement would become a postulate. He tried to prove it. He tried so hard to prove this postulate, and so many other mathematicians after Euclid tried to prove this postulate that their efforts opened a very new kind of mathematics. Their efforts opened a way to a different kind of mathematics, which today we know as non-Euclidean mathematics or non-Euclidean geometry. And so far, from so many years later after Euclid, this statement is now considered to be the fifth postulate. It states that if a straight line falling on two straight lines, so that means there are two straight lines, and on those straight lines there is a third one which is falling on them, or which is intersecting them. Let me say once again, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. It is so easy to understand. Even though the statement is lengthy, it is pretty easy to understand. So what they say, if a straight line is falling on two straight lines. So first let us have two straight lines. This is our straight line 1. This is our straight line 1. And now this is our straight line 2. They have not mentioned whether if the lines are parallel or not. They are just telling us that we have two straight lines and there is a straight line. We have two straight lines and a straight line. Let us name them. Let us name them P and Q, small p and small q. So now a straight line is falling on two straight lines. So we have a third line which is falling on them, falling on these two straight lines. So let this line be A, line A, small letter A. So now if the interior angles on the same side of it, so interior angles on the same side of A, interior angles, these are the interior angles on the same side of the transversal. Okay, even if the lines are non-parallel, the third line is called as a transversal. There is no condition that the lines have to be parallel for the third line to be a transversal. Here line A is once again a transversal. So the interior angles on the same side of the transversal together, that is sum. The sum of these two angles must be, if it is, not must, if it is less than 180 degrees. So let these be angle 1 and 2. If angle 1 plus angle 2 is less than 180 degrees, okay, two right angles, that is if it is 2 into 90, which will be equal to 180 degrees, then the two straight lines, these two straight lines, if they are produced indefinitely, okay, infinitely, if they are produced infinitely, then they will meet on that side, on the same side, on the same side where the sum is less than 180. So let's try producing them here. The sum is obviously less than 180 degrees. So if I were to produce them, if I were to produce these lines like this, let's produce them, see here, they will definitely meet each other. So that is what the Euclid's postulate says. If the sum of the interior opposite angles is less than two right angles, that is if it is less than 180 degrees, then the lines meet each other. When the lines meet each other, they are not parallel. So since it is less than 180 degrees, if it was equal to 180 degrees exactly, if the sum was equal to 180 degrees, so these are our lines, Z, Y, and this is our transversal, B. So now if the sum of the interior angles on the same side, either these two or these two angles, if the sum of these two angles is exactly 180 degrees, then the lines are parallel. That means they do not meet. If you produce them indefinitely on either side, they will never meet each other. It also says that this is the second interpretation. The first interpretation was if the sum was less than 180, then they would meet. If the sum of what? If the sum of interior angles on the same side was less than 180 degrees, then they would meet. If the sum was equal to 180, if, let them once again be angle 1 and 2, angle 1 plus angle 2 is equal to 180 degree, then the lines are parallel. Okay, here they are not parallel. Less than 180 degree, not parallel. Equal to 180 degree, parallel. And more than 180, see here we have angle 3 and angle 4. Here angle 3 plus angle 4, angle 3 plus angle 4 is greater than 180 degrees, right? It is greater than 180 degrees. So when the sum is greater than 180 degrees, the lines will move away from each other. They will never meet. Okay, so when the sum is less than 180 degrees, they will meet. When the sum is equal to 180 degrees, they are parallel. When the sum is greater than 180 degrees, they will never meet, but they are not parallel lines. This is Euclid's fifth postulate. Okay, so in the exercise 2.2 there are two questions which will be your homework. All right, so in your fair book you have to write everything I talked to you today about, starting from point, line segment, ray, parallel lines, transversal, different types of angles when there are parallel lines, and then talk about the Euclid's fifth postulate. Write the statement and the explanation where I gave you about three kind of situations where one there is less than 180 degree, what will happen, when it is equal to 180 degree, what will happen, and when it is greater than 180 degree, what will happen. All these things should be present in your classwork book. I will not give you any separate notes. You have to write them on your own. Listen to the video lecture and write them. Whereas for exercise 2.2, it is for your homework. Alright, so the first question says, how would you rewrite Euclid's fifth postulate so that it would be easier to understand? So Euclid's fifth postulate can be rewritten in various ways. I told you about 4 to 5 ways just now in the video. So it is up to you to write Euclid's fifth postulate the way you interpreted it. Alright, write your own statement for the fifth postulate. That is the first question. And the second question says, does Euclid's fifth postulate imply the existence of parallel lines? So in the statement of the postulate, we just saw that Euclid never says that the lines were parallel. He just says if the third line lies on the two lines, and he talks about the angles there. So do you think Euclid's fifth postulate confirms if the parallel lines exist or not? Alright, if yes, then why? If not, then why? It is up to you to write your answer or solutions for these two questions in your homework book. It should be done right after you watch and complete the video. Okay, in the next class we would begin with your third chapter. This completes the introduction to Euclid's geometry. Thank you.